Again, I'll share what we had. So we wanted to convert our Z law into having a 0 element, and we said because this was a -2, to make this -2 to be 0, I took my new law x, and because I had a 1 here, I multiplied the law by 2 to have created a 2, so that I'll be able to have a 0. So -2 plus 2, I took an operation of a positive or a plus here, and I wanted to create a 0. So how do I make a 0 when I have a negative? That's why the operation of a positive is coming in there as my sign. Now, after I have found, remember what was the main goal was? From our first table, every other element that is along the pivot column, all this to be changed to zeros. We said for S2, we had already had a 0. We were not to interfere with that. But now we have made this one in -2 there to be equivalent to zeros. So what do? We now set our second table. And we are now picking, you can see my X has moved to be defined law-wise, where we had the S1 variable. And on my right-hand side, like for now, if I'm asked, what is the variable of X? I'll just say it's equivalent to 9, which I'm able to read through on my right-hand side column. Okay, so my S2, we said this one we are not changing, the law remains. But S3, we have picked the new values which are formed after we were able to make this one here to be equivalent to 0. So I've used this law to fit it now in my new table. Then my S3 law we will have the new variables as we had found them, and finally we fit in the new values of the Z law. The question is, after we have set our new table, is the solution of 18, our Z here is now 18, is the solution of 18, which we say this is the maximum profit, maximum, or can we say it's optimal or the best solution? No. Why? Because along the law Z, we still have some negative variable of a -1 here. Until this law will not have any negative variable, then it means we have not yet maximized the profit or that benefit. So again, because of this negative one here, the value of Z equivalent to 18 is not, it's not yet optimal. We do what? We identify what we call the pivot column again, the pivot law, and then we do the necessary. So the highest negative variable or element alongside law Z is the -1 here. The highest negative variable or element along law Z is our -1 here, which gives us the pivot column. The pivot column will help us to pick the elements corresponding to that column to divide every right-hand side variable by those corresponding elements in the pivot column to be able to come up with the smallest ratio, which will give us the pivot law. So we start. On my right-hand side variable here is 9, which I'll divide by 0, which gives us an infinite variable, and we have said such a ratio, we ignore it. Then we pick 30, we divide by 2 here, which gives us a value of 15. And lastly, we had an 11 here. We divide this one by 1, we get 11. And remember, we don't take any ratio in relation to log z or your objective function, only for the constraints. And I repeat, it's only for the constraints where you require to get the ratios. By getting the right-hand side variables of those constraints, we divide by the corresponding elements in the pivot column. Now, among the variables, we have said we ignore the infinite variable. Now, between 15 and 11, the smallest or the small variable for that matter is 11, which gives us now, this being our small or the smallest, this 11, it is the one that has made me now to make a conclusion, class, that the S3 is my pivot law. The pivot column, which is my Y here, gives me the entering variable, and the pivot law here, which is my S3, becomes my leaving variable. So finally, the position of S3 will be taken by my column Y, or the variable Y will take the place of S3 here. And finally, on my right-hand side, I'll finally be able to read through the value of my Y at the end of the time. So how do we now change any other element that is corresponding to the pivot column to be equivalent to a 0? We first of all have the elements which will constitute our new entering variable Y. So at the point of intersection, class, between a pivot law and a pivot column, we come up with what we call the pivot element. So my one here, between, or an intersection between column Y, my pivot column, and law S3, my pivot law, this is my pivot element. Now, this is a very unique case. Reason, if I were now to come in and I divide my S3 law by this one, all these elements, for sure they will not change. I repeat, if we were to divide S3 by 1, which is our pivot element here at the point of intersection between the pivot column and the pivot law, since this is just but 1, then it would mean those elements are going to remain constant. And that's why, as I get my new law Y as my entering variable, the values are, or the elements are just but like what we had in our S3 law. Reason, my pivot element being 1, when we divide all this by 1, the result will still remain the same. But now, how do we use this one here, okay, along the law Y to come and we change, class? You can see in our second table, we want now to make all this to be equivalent to 0. That is, we had a 0 alongside law X, so that one will not interfere with it. But on our S2, we have a 2. This 2 must be made to be a 0. And on our Z, we have a -1 here. We have to make it to be a 0. So what have we done? I've used my new law Y to work on the variables or the elements which will constitute what? For the law X, that will remain the same, will not change it. But for the law S2 and also the law Z, those ones we have to change their elements. So we start. S2, the old one, had the elements of 0, 2, 0, 1, 0. On the right hand side, we have a value of 30. To make this to a 0, what have we done? I've taken my new low y, where here we had a 1. To make a 0 between the 2 and 1, I've multiplied my new low y by 2. So that when I come and I subtract at the end of the day, these 2 and 2 will give me a 0. Don't worry what will happen to the rest. Your interest is just that particular value that you want to convert to a 0. That should be the guide when you are trying now to balance, like when you're looking for a value that you can make this to be equivalent to 0, just choose the guide as per what is already in your table. For my S2 here, the value was 2. That's the only thing that I need to take into consideration, so that when I'm introducing my new law, the value here being the simplest that I can choose, later on these two working with them, they'll have now contributed to a 0. And remember, what you do to the left, you also do to the right. So by subtracting every other element from my old S2, that is minus 2 times the new low y, we end up having all these elements, which will give us our new S2 law. Then finally, we had a z with a minus 1 here. How can we make a 0 here? And what I've done with the y that had a 1, 1 and 1 will give me a 0, but with an operation of addition. And lastly, remember, whatever you do to the left, you also do to the right. And I have a value of 29, which is my z value. Now, what do we do after that? We set a new table. So you can see we have invoked what we were calling iteration or iterative, where we were repeating some previous stages to a point that you have formed a new table. So we again form a new table. I've called it a final table. And this final table, I'm going to ask myself before I call it final, when I look at my last law of Z, do I still have some negativity? And if not, then we can say our table will be called final. So when we set our last table, remember our last table is found by now inserting the values that you'll have found or the elements in regarding to the laws that you'll have constituted. My law y, we had said law x is not going to change. Law S2, law Z. Remember, y has actually replaced your law S3. And when we set our new table, we realize what? Our Z law has got no negative values anymore or negative elements. Because of that, we can now comfortably say the value of 29 here on my right-hand side of my law Z is now my optimal value. And so I can say the solution to this particular problem using the simplex method is that the Z value is equivalent to 29 here. Then how do I answer the question in regarding to my decision variables? The x will be equivalent to, you can see the value 9 on the right hand side. What is the y units? This is again equivalent to 11 units here. So you just come and say your decision variable is sitting lowwise and its value will be read on the column, the right hand side value. For the Z, it is actually the highest value that you get, but all these elements alongside column, or rather law Z, they should be all positive. If you still have some negativities, then it means your solution is not yet optimal. What are some of the interpretations that we can make from our last table? One, my S2 was what? This S2, we had defined it from the beginning when we were standardizing our problem as the slack variable related to our second constraint, material RM2. This value of 18 is equivalent to that S2. What does that one mean? We have got some unused amount, which we call a slack in relation to material number 2. We didn't exhaust. Now, for a variable that has got some value, in this case, we are calling it a slack. If that particular variable is no 10, like in this case, you can see we have 18. Then, if I ever want to add more units of such a variable, of such a constraint or a resource, which was our M2, LM2 material, I don't have to go and buy this from any other store. I can just get it from my own store. I didn't exhaust, so no price will be payable. And what does that one mean? A shadow price for a resource that was not fully utilized. In our last class, we said will always be equivalent to 0. And you can now be able to tell what is that shadow price right away from your last table in your simplex method. My S2, the shadow price here is equivalent to 0. But remember, we have not exhausted. That's why its value is equivalent to 18. I repeat, the values that we are reading on the right-hand side column of our whole table gives us the values of our basic variables. What is X? 9. What is S2? Which was a slack related to my constraint number 2, 18 units. What is Y? 11 units. What's the value of Z, the highest? 29 shillings. Now, these figures on my lower edge of my Z law, yeah, in relation to our various slacks that we had already introduced, the S1, S2, S3, when you go down column wise, okay, on your law Z, these ones are usually interpreted as this. They are usually interpreted as the shadow prices. I repeat, these three, which are in relation to our three constraints. If we want to have any addition of a unit in relation to our three constraints, how much would we pay as the extra amount per that one unit? For me to use an additional unit of M1 material, I have to pay a third of a shilling. If I want to pay for a unit of M3 material, then I'll pay 1 shilling. But for M2, because we had a balance, then we are paying a 0 price. Now, there are these two variables again here on my lower edge of my law Z, column wise. These ones, which are now relating to our decision variables class, they are called, these two here, they are called the slacks. This will be called the slack variables of the exhausted materials for M1 as well as for M3. When we interchanged our X with our S1 and also Y with our S3, because these ones were now entering the positions of those two variables. So these two are actually the slack variables of RM1 as well as RM3 respectively. But these ones have said they are usually called the shadow prices of the constraints or the resources which you are using in your analysis. Lastly, I would want to compare my objective function variable was to be given by what? Our Z was to be contributed by an equation of the kind, remember where we are coming from, right away from the beginning, 2x plus y. So if I come from my table here, I am given the value of x, I'm given the value of say y, assuming this was our final solution given and you're doing the interpretation. What do? You just substitute the 2 in your objective function equation, and so you'll be able to find the maximum or the optimal value. And again, what I've talked about here, you may be asked also to do an interpretation, let's say in a particular problem. So I've unmuted all of you. You may ask some questions in regard to our class now. Can you hear me, Mariana?
Yes.
Any challenge?
No.
Anyone with an issue you'd want me to clarify? Is there anyone who has not understood my presentation for today? Musiri, you're okay?
We're okay.
Okay. I'll take you through another illustration, still on the simplex method. If we do maybe another example, I suppose we can be able to understand the steps. Is that okay?
Yes.
Yeah.
Good. And then once we have done one more illustration, I'm working on an example on minimization, which I'll share maybe on Wednesday, so that I take you through that. And then after that, I hope we can go through a few illustrations on the transportation and assignment. But at least we finalize on this topic of LP. Okay, again, make sure you can hear me talking of some of the terms, and I keep on stressing on these because you realize that it's not always about computations. At times you may be given a question, but part A, Roman 1, Roman 2, maybe you are required to, let's say, define. So those terms are very, very important. Make sure you familiarize yourself with that. So if there is no burning issue, we can close our.
Mwalimu. Mwalimu.
Yeah.
On the second row, S2,
Mm-hmm.
on the right-hand side, the 18, is it supposed to be 18 or 8?
18.
But they have done there 30 minus 22.
Yeah, we had what?
30 minus 22.
Let's go back there. This was our low S2, yeah? Previously we had
Yes.
0, 2, 0, 1, 0, and 30. Then we have taken what? We have taken our low y, whose values were 0, 1, minus a third 0, 1, 11. We wanted to create a 0 where we had a 2 here. So we have S2.
Yes.
New one to be 0, 0, 2, 2, 0. Then this will be minus 2 there, 2 all over 3 there. And then here this is 1, negative 2. What is 30 minus 22?
8.
This is 8, huh?
Mm.
It should be 8, huh?
Yes.
Positive.
Yes.
So you can make a correction for me there.
8.
Yeah, it says positive 8, not 18. And finally, you do the adjustment. Thank you for that. I'd not even seen I made a mistake there. And you do the adjustment on our value of the constraint RM2, the slack value to be equivalent to 8. Is that okay?
Yes.
This one here should be a balance of 8, not 18. And you can also do it this way. Let's see. This is our constraint. This one here. 0x plus 2y less than or equivalent to 30. Our final value for y is 11. Huh? So if you are to multiply 2 by 11, you will get 22. Of course, we have not exhausted. You see the balance will be equivalent to 8. So make a correction there. Sorry for that. Okay?
Yeah.
Is there any
Yes.
other
Yes.
any other thing?
Paddleship gearbox incorporates launch control, and so easy to engage your ground.
Okay, so we call it a day. Once I've set another session, I'll let you know. I'll post it on your WhatsApp. Also, I did post our last class session. So again, look at that. Those who missed, and if there's anything that you didn't understand, you can also ask for more explanation. I had the meeting.
Thank
Now. Is that okay?
Yes.
Okay. Bye.
Bye.
Or S3.